So here we have the 2023 paper, question 5, involving differentiation. So we're just going to be going through it just step by step, just so any questions that arise, hopefully they're answered in this video. So question 1 of part A says the function f is defined as follows: for x being an element of R, f of x is equal to 1 over 5x squared plus 7. Find f prime of x, the derivative of f of x. Give your answer in its simplest form. So there's two ways to do this. First of all, we have one number over another, so we can go straight ahead and just do the quotient rule. Where the top one's going to be u and the bottom is going to be v. So if we do that one, we're going to have u being 1, so du is 0. And then if we have v is equal to 5x squared plus 7, the derivative of that is going to be 10x. So if we go through it, we're going to have 5x squared plus 7 multiplied by 0 minus 1 times 10x, and this whole thing gets divided by 5x squared plus 7, all to be squared. So if we look at that, this 0 cancels out the 5x squared, so all we're left with then is going to be negative 10x all over 5x squared plus 7, all to be squared. And this is using quotient rule, which is v du minus u dv all over v squared. The other way we can do it is using the chain rule, and that's by noticing that f of x can be rewritten. Anything that's 1 over and then the something on the bottom of it, we can rewrite that as the bottom number to the power of negative 1. So this is actually equal to 5x squared plus 7 all to the negative 1. So if we're finding f prime of x, then we're going to first of all have to differentiate this upper power. So we're just going to have to decrease that by 1 and multiply by the other power, same as always. So then we're going to have minus 1 multiplied by what the inner function is, 5x squared plus 7. Drop it by 1, we have the negative 2. And now with the chain rule, we also need to multiply the derivative of the inner function. So this all gets multiplied by the derivative of 5x squared plus 7, which is 10x. And if we multiply all that out, we're going to have minus 10x multiplied by 5x squared plus 7 to the negative 2. And then if we tidy that up, we just have negative 10x all over 5x squared plus 7 squared. So you can see these two are the exact same, just using two different methods. So, secondly, we're going to have this question. The function g of x is defined as follows: for x is an element of R, where x is some number between 0 and pi. Some number between 0 and pi. G of x is equal to the tan of x over 2 multiplied by the natural log of x. Find the value of g prime pi over 2. Give your answer in the form a plus the natural log of b, where a and b are real numbers. So, looking at this straight away, we have some function multiplied by some other function. So since it's multiplication, we're going to have to use the product rule, which, if you can remember, is u dv plus v du. So this is going to be u and this is v. So we have u, which is equal to the tan of x over 2. That means that du is equal to sec squared of x over 2. And because its inner function So if we go ahead and look at part B of this question, we have the function g of x is defined as follows: for x is an element of R, where x is some number strictly less than pi and strictly greater than 0, where g of x is equal to the tan of x over 2 multiplied by the natural log of x. Find the value of g prime of pi over 2. Give your answer in the form a plus the natural log of b, where a and b are real numbers. So if we're looking at this, we can see that this is multiplication of one function and another function. So first of all, if we're using the product rule, we're going to have to use the product rule, which is u dv plus v du, where the tan of x over 2 is u and the natural log of x is v. So u, we're going to have the tan of x over 2, and if we find du, it's going to be equal to a half sec squared x over 2. Why is it equal to that? Well, tan of x over 2 is the same thing as tan of a half of x. Because we have a half multiplying the x, or we have x divided by 2, we have x being acted on by something else, and then it gets plugged into tan. So we actually had to use the chain rule right here. So we multiplied by the derivative of what was in the inside. The derivative of a half x, well, the x just goes to 1, so that's equal to half, which is why we had to multiply it back in here. And then we have the derivative of tan is equal to sec squared. So if we continue doing this, we're going to have v is equal to natural log of x, and the derivative of the log of x, or the natural log of x, is 1 over x. So now we can use the product rule. So u is tan of x over 2, and that gets multiplied by dv, which is 1 over x. And then we add v, which is the natural log of x, multiplied by du, which is half sec squared x over 2. Now, if we look at our rules and we go to the section all about trigonometric identities, what we have here is a half sec squared. And if we look at the very top, we have the sec of a is equal to 1 over the cos of a. So that's what we can use. So if we have sec of a is equal to 1 over cos of a, it means that sec squared of a is equal to 1 squared all over the cos squared of a. So right here we have a half times sec squared, as we said, was going to be 1 over cos squared pi over 2. Sorry, x over 2. And it just makes it a little bit easier to deal with. So if we go ahead and find g prime pi over 2, that means that we now have the tan. And if we stick pi over 2 over here, we're going to have pi over 2 divided by 2, which is pi over 4, plus 1 over pi over 2. And then we have the natural log of pi over 2 multiplied by a half, which again is multiplied by 1 over cos squared pi over 2, divided by 2 again. So divided by 2 again means that we're going to have pi over 4. Remembering these, tan of pi over 4, we have the cos squared of pi over 4. What do we get? Well, if we go back to the tables again, we have tan down here, and if we look at where pi over 4 is, we can see that that one's equal to 1. And then if we go to 1 over cos squared, we're going to have cos of a. When we stick in pi over 4, we're going to get 1 over 2. So right here, this is equal to 1. This second one, we just flip the bottom fraction, so then we get 2 over pi. The natural log of pi over 2 stays the same, half stays the same, and this one goes to 1 squared all over 1 over root 2. Both of them are going to be squared, so that's going to be equal to 1 over 2, or 1 over a half, sorry, which is just equal to 2, because again, we flip this bottom one. So this whole thing is going to be equal to 2. So if we go ahead and simplify it, we're going to have 1. That shouldn't be a plus there, apologies. Multiplied. 1 multiplied by 2 over pi. And now we have to add on the natural log of pi over 2. And again, we're going to have to multiply this whole thing by a half and 2. So in the end, we're going to have 2 over pi plus the natural log of pi over 2, because 2 multiplied by a half just gives you 1. The B, G is a mapping from B to C. The number of elements in A is the number of elements in C, which is 4, and the number of elements in B is equal to 3. Find the value of G of f of 3. So whenever you have anything written like this, we have G of f of 3. What we want to figure out first is what happens when you stick 3 into f. So say, for example, f of 3 was equal to 2. We'd have f of 3 equal to 2. So we now stick this into G. So then we'll be looking for G of 2, where this 2 comes from f of 3, and this whole thing just gets snapped all the way back. So if we look at this set, we're looking for f of 3 first of all. So set A, this one over here, what happens with the mapping f? So if we go from 3, it sends it to this picture of the Earth. What happens when we stick this picture of the Earth into the function g? It goes to w. So in the end, we have g of f of 3 is equal to w. So explain why g B to C is injective but not surjective. That is one-to-one but not onto. So we don't really need to worry about what's happening in A. So we look at B and C first of all. What we want to notice is that if we look at everything in here, the plane, the world, and the rain cloud, they all get mapped to one thing within G. So everything in B gets mapped to G. So that's okay. So that's why we can say that this is going to be injective. Now, why is it not surjective? Surjective occurs when everything in the subset gets mapped to by something in the primary set. So if we look at B again, B maps 3 things to X, W, and Z, but nothing gets mapped to Y. So if we were writing down anything, we know it's injective because B maps every element to C. And why it's not surjective, not every element in C gets mapped to from B. And there we have it.